All right, 6th graders, lesson 58, probability and chance. And we use those terms quite loosely and a lot of times incorrectly, so hopefully today we'll get an idea of when we should be using it. And the book presents some ideas in the beginning. What is the chance of rain on Saturday? What are the odds of winning the big game? And what is the probability that I will roll the number needed to land on the winning space? Probability tells us how likely it is something will happen. And so if we put probability here, probability goes from a scale of 0 to 1. 0 meaning it is impossible, and 1 meaning it is certain it will definitely happen. So usually when we express probability, we are talking about a fraction, 1/2, or it's got a 3/4 chance of happening, or a 1/4 chance of happening. So your book gives there the probability of rolling a number cube. If I roll a number cube whose faces are numbered 1 through 6, the probability of rolling a 6 or less is 1. It's certain. I'm going to roll a number 6 or less. The probability of rolling a number greater than 6 is impossible, so that would be a 0. What is the probability of rolling just an even number? Well, I've got a 2 and a 4 and a 6. That's 3 out of 6, so the probability there would be 1/2. So on this scale, events that are closer to 0 are less likely to happen, and events that fall closer to 1 are more likely to happen. So we kind of assign a probability to a certain event, saying the probability of it happening is much greater. If you turn the page to page 3, there you see a spinner. A, B, and a C. And if we were to spin the spinner here, what is the probability that it would land on a certain area? Well, the probability of A, that would be 1/2. And the probability of B would be 1/4, and the probability of C would be 1/4. You add those up, and we would get 4/4 or 1. So the probability that it will land on A, B, or C is 1. It is certain. It must happen. Now we can also re-express those fractions as decimals as well if we want. 0.5, 0.25 plus 0.25. We add those up and we get 1.0. So again, it is certain. It will definitely come true that we will land on an A, B, or C. All right, if we take a look at example 1 here, it says Meredith spins the spinner shown above here 28 times. About how many times can she expect the spinner to land in sector A? Well, I know that should be half. A is about half of the circle. So she's going to spin it 28 times. And now I can go ahead and do my math here. I cross or diagonally multiply and then divide. So 28 divided by 2 will be 14. So I expect the spinner should land on A about 14 times. Not guaranteed, but it should be somewhere around there. And then I ask myself, how many times will it land on sector B? Well, again, that will be 1/4, and she's going to spin it 28 times. So I am going to cross multiply or diagonally and then divide by 4. 28 divided by 4, that'll be 7. So the probability of it landing on B, or the amount of times it will land on B, is about, I'm guessing it'll be about 7 times, and then the same thing would be for C. It would be very unlikely for it to never land on A, since it has so much space. It's a little bit better odds that it might not land on B or C. Now, I also want to use right here the word chance. What is the chance that it would land on A, B, or C? Well, chance is always dealt with a percent. So what is the chance it will land on A over here? We'd say that's a 50% chance, because 1/2 is equal to 50%. What is the percent chance it would land on C? That's going to be a 25%, and B would be a 25% as well. So chance always gets expressed in percent, whereas probability, as we saw, gets expressed usually with a fraction. So that's probability, and that is chance. So let's take a look at example 2 here. In Miami, the chance that it will rain on a typical day, so rain equals 60% chance. Find the probability that it will rain on such a day. That'd be 60%. What is the probability it will not rain? Well, all right, so probability, this is chance here. So we want to know what the probability is. Well, that's 60 over 100. If we reduce that, we get 6 over 10. We reduce that, we get 3/5. So the probability of it raining, would be 3/5. The percent chance of it raining will be 60%. So we can express that both ways. And then what is the probability it will not rain? Well, that'll be 40% chance of not raining, which equals 4/10, which equals 2/5. So again, now you see that if we add these two numbers, they should equal 1. It's going to happen. Either it's going to rain or not going to rain. That is certain. So again, when we're dealing with chance, we want a percent. When we're dealing with probability, we want a fraction. All right. Then it's time for us to go on to the odds. Actually, we're going to stay here with probability. All right. So again, we express that as a fraction. The numerator is the number of outcomes in the event that actually happened, like how many times does this happen, and the denominator is the number of possible outcomes. So, for example, I was going to roll a dice. Well, the number of possible outcomes, I've got 6 different possibilities because there's 6 different numbers, and I'm asking maybe how many odds there are. Well, there's 3. So the probability that I roll a odd number is 3 out of 6, which I need to reduce to 1/2. So maybe I ask myself, what's the probability of rolling a number greater than 4? Well, again, there's a total of 6 outcomes, total possible that I could get. I could roll a 1, a 2, a 3, a 4, a 5, or 6, so 6 total possible outcomes. But what I'm focusing on is I want to know what is the probability that I'll roll a number greater than 4. Well, greater than 4 means it's got to be a 5 or 6, and that's only 2 numbers. So I will put a 2 up here, and again we need to reduce 1/3. So the probability of me rolling a number greater than 4 is 1/3. And that's example 3. Example 4, we see we've got a bag containing, well, let's go ahead and do that. There we got 5 red marbles in the bag, 4 yellow, 2 green, and 1 orange. So now if we add all those up, that's going to tell us our denominator. 5 plus 4 is 9, plus 1 more is 10, 11, 12. So I've got a total of 12 possible outcomes here. And without looking, it says Brendan draws a marble from the bag and notes its color. What is the probability that it is red? Well, there are 5 red, so the probability is 5/12. I cannot reduce that. So the probability of pulling a red out of this bag is 5/12. Example 5 asks, in the experiment, in example 4, what is the probability that the marble Brendan draws is a primary color? And remember what primary colors are. They are red, yellow, and blue. I don't have blue marbles, and I don't have, but I do have yellow and red. And that's 9. If we add the 5 and the 4 together, that's going to be 9. So the probability here for example 5 would be 9 out of 12, which I can reduce to 3/4. So that's a pretty good probability there. Again, on our probability number line of 0 to 1, 3/4 is way over here, so it's more likely to happen. Whereas 5/12 is a little over here, it's closer to the less likely to happen. So we're always analyzing those numbers, taking a look at probabilities and chances, and trying to determine you. Remember, percent always has to do with the word chance, and a fraction always has to do with probability. That's it for today. You can get started on your lesson.